శనివారం ఉండడు. बच्चे फोन कर रहे हैं,
क्या खबर है इसमें?
साइन कराने, पता नहीं कौन सा।
अच्छा, उसमें थोड़ा अपना वो कहा देना अपडेट सर। देखने अपने मेरे कुछ आप
ఓకేనా?
Sir, shall we start?
ఇంకా సౌండ్లు వస్తున్నాయి చూడు ఇక్కడ. ఓకే, can we start or wait for some time?
24 participants are joined.
So wait 2 or 3 minutes. This video around 1 hour video.
So you have to finish before 3 o'clock.
Okay, no problem. 40 minutes, around 40 minutes.
Sir, we'll start, sir.
Yes, yes.
So good afternoon to all of you, and I welcome you all for the today's afternoon session. Afternoon session consists of two small sessions. So one is the virtual visit of soya milk plant that is handled by the Professor Swardi sir, and another session 2 hours slot that is handled by the Panikumar from National Institute of Ocean Technology. So now I request Professor Swardi sir to hand over the session and give.
Okay,
Soya
sir.
milk.
My voice is audible?
Yeah, yes, sir.
Yes, yes. Okay, thank you. This session not a lecture. It's only lab visit. All are knows regarding. I already mentioned. After education, employmency is the major target. We are the job creators or job seekers. So two things are there. We want to develop our students as a job creators, not a job seekers. If we are creating our students as a job creators, then local employmency we are capable to give in mechanical field, especially concentrated with food processing. All are knows the milk demand and supply. The demand and supply 50% difference is there at present 2021 itself. It is projected to 2040. Demand 100 liters demand is there, means our production capacity only 20 liters. That much of difference is there in future. That gap, how at present these milk collection centers, how they are filling the otherwise local milk processing plants, they are procuring milk powder in the chemical form from where it is available from other countries. Second thing, they are creating false milk, especially we can see in Madura, Agra railway stations. 5 rupees, they will give 200 ml tea. With 5 rupees cost, they will give 200 ml of tea. The milk cost itself 5 rupees. How they are giving this 200 ml means this is a prepared milk. So instead of that, we are capable to substitute the milk. Milk, what is the purpose of milk means it will add the calcium, first thing. Second thing, minerals, we are getting minerals and some fat we are getting with the milk. Fat is dangerous, that's why we are not drinking more milk, we are moved to the cow milk like that. So elimination of the fat and increasing the proteins and vitamins, it will add more advantage compared to general milk. So one of the option is soya milk. Soya milk all are knows, but in our institute we developed the own protocol for preparation of the milk, and we established the plant also. So today's our organizers requested at least we will visualize the plant, means it will get advantage to the faculty. That's why I'm now I'm sharing the screen of our plant. Around this is 40 minutes time it will take from the seed to cake, means paneer preparation. Up to seed to paneer preparation I will visualize. Generally it will take 3 to 4 hours time, but for time slang already we recorded that unnecessary time I removed and actual process only visualized. I think it is with this interaction. Now I am sharing my screen. 1 minute. Yes. So now we see this is the soya seed. You can see we soaked, actually we developed our own protocol. I mentioned generally soya seed generally they are soaking at different temperatures. Some of the plants they are soaking 40 degrees, 30 degrees, 45 degrees, 50 degrees also. but general soaking at 20 to 25 degrees temperature and 13 to 14 hours, it will give the best yield. So we generally today I want to make milk means at least yesterday night I am doing the soaking process at 10:30 or 11 o'clock. You see, after soaking, we are cleaning the seed. Total skin we are separating. That skin we are giving feeding to the animals, and also soaking also we are doing. Uh, Means absence of oxygen. Whatever the oxygen in water is available, that is only. General not exposed to the general air. That is our target. At present, generally we don't have any vacuum chamber, so we are fully filled with the water. That chamber, absence of air, we are soaking. Next, after soaking, we are cleaning the seed and skin removal we are doing. Next, this is the boiler, small boiler. You can see, I will show. First, this is the small boiler. At present, boiler already on 1.5 bar pressure, steam is ready to supply. This boiler capacity 4 kgs per hour steam generation. That is more than sufficient for our batch. This is the grinder cum cooking unit. So whatever the seed we soaked, that seed first we are pouring into the grinder. You see, this is the grinder unit. So 90% skin we removed. And you see in grinder at present temperature, the temperature is, I think, ambient only, 20 degrees temperature at present. In the grinder, the pressure also normal, zero pressure. There is means ambient pressure only. There is no pressure rise. I think 12 liters of the water we are adding for batch. Batch contains 2 kgs of the seed per batch. For that, 12 liters of the water we are adding after soaking of the seed. Seed will absorb 4 to 5 liters of the water, entire night soaking. Then after we are closing the wall, that pouring wall. See. Now we are started in supplying of the steam. Why? Because in this grinder, we are doing cooking and grinding simultaneously. Cooking up to 1.5 bar pressure and 110 degrees temperature, we are doing cooking. And grinding generally 5 to 6 minutes time it is taking based on the soaking of the seed. But effective soaking of the seed, it will take 3 to 4 minutes. See, from the boiler. Now, general gas fired only. Small vessel only. You see. Now, once we opened the wall, earlier 1.5 bar pressure is there. Now it is reduced to 1 bar. Because our helper stopped the gas supply. Because of that, whatever the steam is there, generated steam, it is went into the grinder. So pressure drop takes place in the boiler. Again, we are giving fire. The boiler pressure will increase. Generally, boiler pressure we are maintaining 1.5 to 2 bar, and grinder pressure 1 to 1.5 bar. Then only supply of steam from the boiler to grinder will take place. Otherwise, from the grinder, steam will enter into the boiler. We are maintaining it. And this is the RO water collection tank only. Why? Because we are not placed the RO processing plant. This RO processing plant for the institute, one centralized processing plant is there, 2000 liters per hour capacity. From there, directly we are getting the RO water. Well, because if RO water we are using, the softness of the milk will increase. Otherwise, milk in a hard condition. This is a plant. It is our institute. I think. See, yes. Why? Because my building is away from our regular activity class work. Why? Because we are doing processing work, some water smells are coming. So it is not acceptable to the education institute. So separate building is available in our institute R&D building. This is the boiler. Now they provided fire. Let's see. This is the water level meter. How much water is there? Through pump only, this RO water we are supplying into the boiler. If water is reducing, through circulating pump, we are supplying the RO water. Now you see the pressure earlier 1 bar pressure. After giving fire, the pressure is rising. After 1.5 bar pressure, we are again starting supply of the steam to the grinder. Yes, it is crossed 1.5 bar. Yes. It is crossed. It is reaching around 2 bar pressure. Now all is slightly opened. You can see temperatures now started rising. Earlier 20 degrees temperature. The pressure at normal only. And we started at the grinder. This is the grinding unit. Carbon blades we are using this in grinder. Then after this is a vacuum chamber, suction chamber. Two suction chambers are there. Whatever the cooked soya seed paste is there, directly we are sucking into the second chamber. And two suction chambers why we placed means something is missed means it will not enter into the vacuum pump. Again, one more suction chamber is connected. For this suction chamber, we are connected one vacuum pump. By this vacuum suction operation, what is the main advantage means initially we are sucking the water while cooking and boiling. Soya milk major drawback the waterness of the item, major drawback of the soya milk. So we are capable to eliminate this waterness. Aspiration, aspiration, aspiration. that one only is good. Aspiration. Aspiration. Yes. Yes. You see, the pressure is around 2 bar. So I want to remove the water after cooking time. More by steaming operation, more water is coming. That water first initially we are sucking by the vacuum pump. Entire water we are sucking by vacuum pump. That water is absorbed by the vacuum pump circulating water. So by the suction of this two advantages. One is from the grinder, we don't want to open the grinder. Entire paste, whatever the soya paste is there, entire paste, liquid indirectly, not paste, total liquid we can suck to the second chamber, preparation chamber. One advantage, no manual intervention. Second advantage, we are capable to suck the water also. 90% of water will absorbed by the vacuum suction. That's why two chambers we given. At the time of suction, some liquid separately is coming, means it will enter into the second chamber also, because our vacuum pump capacity is 1 HP. Generally, that is sufficient for 4 kg loading capacity. But at present, we are doing only 2 kg loading capacity per batch. For that only, second chamber also we connected. So by the suction operation, water we are removing. That is main advantage. You can see now in grinding chamber, the pressure is rising around nearer 1 bar. It is coming. Earlier it is in zero condition. Now it is coming around nearer to 1 to 1.5 bar, and temperature 110 degrees. Up to 110 degrees, we are cooking the soya seed. Now you see the temperature also reached 100 degrees. But for this time, it will take at least 30 to 20 to 30 minutes time. For reducing the time, that only cut videos all we merged. Neoprene rubber sealing. The entire chamber, all joints are connected by the neoprene rubber sealing, and it is a steel also SS, but not boiler grade. Boiler grade steel only we are used, but not certified. Small capacity, that's why there is no certification. Otherwise, we have to take, if large boiler we are using, means first we have to take the certification of boiler. Yes, almost it reached the 110 degrees. If it is crossed 120 degrees, means again it will come, that spoilage of the flavor will take place. Less than 120 degrees only cooking has to take place. And also that cooking not by flame cooking, that cooking by steam. Earlier I mentioned 12 liters of water we are supplying and 4 kgs of steam. Total 16 kgs of liquid for 2 kgs of seed. 2 kgs of seed I am loading, means 16 kgs of liquid we are supplying. Finally, we will get 16 liters of the milk, around 16 liters of the milk, and 2 to 3 kgs of the okran we will get. So 2 kgs I loaded, means around at least 16, at least 14 kgs of the milk we will get. Per kg of seed we will get the 7 kgs of the soya milk. You can see now almost we are reaching 1.5 bar pressure. Yes, temperature also reached. If it is crossed to 120, it is danger. So we are stopping the steam supply. It's all Yes. This is the vacuum pressure gauge. Yes. Water supply to the vacuum pump. It will absorb the entire water and the suction of the soya paste to the collection tank. Two operations at a time we are doing. We are creating negative pressure by the vacuum pump. Once we open the valve, automatically in the vessel will come to the positive pressure. So entire valve we are not opening from the grinder to the collection tank. According to pressure management we are doing. For entire operation, it will take maximum 2 minutes time. Total section of the paste, soya paste. If it is fully grinded and fully cooked means within 1 minute we can suck. Sometimes what happen, continuation batch, some of the seed unable to grind also. So holding of the seed is taking place. It is not reaching the carbon blades and grinding is not taking place. At that time, suction is too difficult. Again, we have to open the cooker, this grinding unit, and we have to clean the unit. Again, we have to supply the entire process. It is time taking process. So proper grinding we are doing means we can eliminate wastage of time. Number of batches per day we can increase. Per hour generally for cooking operation, 2 batches we can come into the picture if we are not making the cake. This is as you see, second suction tank, the soya milk is entered due to the high capacity of the vacuum pump. First, we are emptying the second tank, but because second tank maximum liquid only will enter, not solid. Majority of the solid will accumulate in primary tank only. This is the collection tank. See. Next, yes, this is the cream of soya with okra. That jali we are using for separation of okra and milk. You see, now we are collecting directly milk. Entire okra will kept on jali. Milk capacity I already mentioned. Maximum 12 to 14 liters of milk we can get per batch. That is the detergent. It indicates the pH is positive range. How the positive range is coming means that is a trademark. Generally, soya milk pH range is negative. How we converted, that is a protocol we developed. Uh, we are planning to apply patent. That's why we are not disclosing what method we used to enhance the pH to basic range. Generally, soya milk pH is 6.2 to 7. Our soya milk pH range is 7.28. And water free. Just we are checking if any solid is stuck inside the cylinder or not. Nothing is there. So we are for this separation. Generally, we are using at present manually. If the batch capacity around 50 means we can use centrifuge. By centrifuge, we can separate okra and liquid. But at present, only 14 liters capacity. Centrifuge is not economical. So we are doing manual separation only from solid to liquid. The solid high protein value having the solid, that solid at present some of the that chickies and mill maker at present we are using the solid, but in our plant the solid we are feeding to the cows and buffaloes. Their milk productivity is increased compared to earlier. At present our seeding 2.5 kg, 2 to 2.5 kg of solid we will get, because the total moisture we can't remove. That's why the weight will increase. Generally, 2 kgs of seed we are taking. How 2.5 kgs of okran is coming means total moisture we are not removing. That accumulated moisture weight also is coming to the picture. Around 2.5 kgs okran is coming. So pressing unit. These all are manual pressing. If it is crossed 50 liters per batch means we can do that one. This is a flavor mixing purpose milk circulating pump. We are circulating the milk with adding flavors if it is required. Generally, badam pista flavor is flavor taste is good compared to other flavors. We have all types of the flavors with us: mango, kismis, and milk itself. 5 to 6 flavors of milk also available. These flavor suppliers generally it is available in Bombay, Bangalore, and Delhi. 3 centers. Now, whatever the detergent is coming, we are removing that one. So this is the milk preparation from the soya seed. Here, two things I am not disclosed. One thing, how the pH is enhanced. Second, texture of milk. Generally, we are drinking milk means in the on the tongue. After 10 minutes, 20 minutes, uh, nothing is holded. But soya milk, you drank soya milk means some taste is holded on tongue. We removed that one also. These two are our own protocol. This is the okran you can see. It's like cake. This one we can with adding maida we can prepare the biscuits. We can prepare the cakes. But mostly at present all chikkis, not chikkis that namkeens all coming based on this powder only. Some maida or rice powder they are adding. Next, for breaking of the milk, generally citric acid generally all are using, but using of citric acid wastage of water is taking place. Because citric acid have the water taste. That removal of that water, I want to dip the paneer in cold water at least 3 to 4 batches. So I am as an energy alt, I am not ready to accept that one. That's why we are not adding citric acid for cracking of the milk. For cracking of the milk we are adding calcium lactate. Main advantage, calcium lactate, there is no water, no special water, it's a silent. Second thing, by the calcium lactate cracking, calcium is added to the milk. We are adding calcium to the milk, it is adding advantage. Because in my paneer also, calcium equivalent to milk we will get, more than milk, not equivalent. So calcium is good for health, for bone strength, enhancement of the bone strength. So for cracking agent also separately we are using. This is the milk generally just any batch we are taking. Just we will see what is the condition. Now we are adding calcium lactate. At 80 degrees temperature, we are cracking the milk means it is called paneer. At 35 degrees temperature, we are cracking the milk is called cheese. Now we are making paneer, not cheese. Just whatever the milk I removed, that milk also I poured. Generally, we are taking some milk and we are preparing coffee and like. But today we are not planned. That's why remaining milk also we poured in the cracking tank only. So now the milk is cracked. You can see water and paneer is separated. Just our technician will visualize. Yes. Just we are seeing entire milk is cracked or not. If it is not cracked, again we have to add some calcium lactate liquid. Generally, 100 grams liquid we are using for cracking of 15 liters. But based on the storing time, if it is stored more than 1 year, like that means at least 200, 300 grams of calcium lactate you want to add. Calcium lactate suppliers in Hyderabad suppliers are good compared to Madhya Pradesh. So because we procured from both the parties, but Hyderabad party calcium lactate is good because it's a powder, very good powder state and easily mixing with the liquid. That Madhya Pradesh some rough nature. It is not mixing with the water. Some of the mass is wasting. So total cracking is taken. So water is separated and the cake is separated. Now we are removing the water. One more jali we used. This is local made only. According to our need, small equipments we prepared ourselves. So just I am placing that one. Total liquid will come top side and the cake will settle in downside. This water also generally at present we are wasting, but this water also is good for animals. So full-fledged plant running means this water and that okran we can feed per batch one animal we can feed as a free food. Their productivity will increase, their proteins levels of the milk of cows will increase. At present this water we are wasting only. You can see entire operation I used only one supporting staff, not more than that. Because manpower cost is main expensive compared to other cost. Equipments we can purchase from the head single investment, but operation cost is very important. For at present operation, one only with one technician I am capable to produce the milk and paneer. For cleaning purpose, one aya I am maintaining. So with two manpower, now we are capable to produce at least per batch 15 liters means per hour 30 liters. 200 liters per day. Two manpower cost is added. Now you see, you can visualize the cake. This is the paneer tray. This is a cotton cloth available at any cotton shop, Khadi Bandar. It is capable to hold the temperature around 90 to 100 also. So entire liquid will drain from this cloth. Solid only can hold. You can see our supporting staff not weared any gloves and all. For your hygienic purpose, if I am showing that gloves and all at 90 degrees temperature, it is not recommendable. You want to be healthy and clean himself. in that high temperature, some other chemicals will add to the paneer if we are using any glazes and all. For low temperature operation, we can use the glazes and all. Once they are coming inside the plant means I am not allowing outside up to completing entire operation. So remaining liquid, yes. This is also some automation we can introduce, but small capacity, 3 kgs per batch only cake we are preparing, not a cake, paneer, 2.5 kgs paneer we are getting, 2.5 maximum 3. If proper pressing we are not doing, 3 kgs of paneer will come. So for this 3 kgs we can't make automation. And also our main target milk only. For you purpose only paneer also I am visualizing. Because milk demand is more. This soya milk by steam coffee, not general coffee making. By steaming operation, you prepare the coffee means you will feel very good taste. And all flavored milk you can drink. So many proteins, vitamins are coming. It is very good for pregnant ladies and hair fall candidates, especially. We can reduce the hair fall condition. These all testing reports are available in market. Also, we also tested our milk with the Vimta Labs and SGS technologies. So, importance of soya milk, every person knows already. This before independence we started, but full-fledged commercialization not came by because at that time the demand of milk and supply is equal or more than supply is available compared to demand. At present, demand increases, supply is decreased. So substitution of the milk is required. That substitution by the quality milk, waterless and attractive taste and high protein, we are capable to substitute. Means this is very good business. Single, this is the plant per batch, 15 liters batch. If we are capable to run this plant, means in like Nandala town, one plant you are running per day 200 liters you are selling means around 1 lakh to 1.5 lakh rupees income you will get. So this is the entrepreneurship activity. So we are not job seekers, we are job creators. And also there is no competition. One student is developed in Nandala, means another student, small plant, he can run in Vijayawada, or he can run any village, any mandal headquarters, they can run. There is no competition. Small clusters will give good taste and good maintenance also. There is no cold storage facilities and all. According to demand, we are doing. Paneer demand is there. Night time, I'm running the plant for preparation of paneer. Or early mornings, I'm preparing for milk like that. With this small plant only, I can earn more than 1.5 to 2 lakhs according to the marketing strategy. While we are going job, maximum we will get 10,000, 20,000 rupees at present condition. Better. This is like this activities will give the self-respect also. Here we are doing the pressing operation. Pressing generally how we are doing is that person is tightening the threads. Where hardness is coming, we are stopping. And we kept the load like that only. After some time, again some gap will come. Then gently we are rotating the load. No, no force, by gentle operation, and we are removing the moisture, the liquids. Just after removing, it will take at least half an hour time. Just we clubbed the videos. That's why immediately it is completed. Yes. Slow. Generally, general paneer, the buffaloes like that paneer, 350 rupees like that. Cow milk paneer around 250. Soya paneer less than 200 we can sell. We will get the profits. So 2 kgs of seed we are capable to produce 2.5 kgs of the paneer. Actually, for that removal, generally we are pouring some cold water, but our technician directly is removing cloth. Sometimes it will not come. So better operation, you pour some cold water, easily we can remove the cloth. If camera is there, means they will feel some tense mode. There's these two staff only with me. Yes. We are removing this unwanted exposures. Because one cake generally it is coming 250 grams. This unwanted exposure, they may feel it is not good like that. Yes. Yes. Now we are making pieces. Each piece contains around 250 grams. We can't give exactly. Sometimes it is more than, sometimes it is less than. But 250 grams is common weight. So there is a single piece. For hardening purpose, we are pouring cold water. By this calcium lactate cracking, single batch cold water is more than sufficient for hardening of the paneer. Once it is hardened, by vacuum packing, we are doing packing. Uh, the maximum life is 4 weeks after manufacturing, after producing of the paneer. Within 4 weeks, we have to consume. And storage facility, general refrigerator is more than sufficient. We don't want to place in deep freezer. You can see how smooth it is, equivalent to the buffalo paneer. Thank you. Yes. Uh, with this, I think you people are enjoyed the visit of the plant. If any time offline FDP is there, means one day training also we are giving how to prepare. And at that time you can see our protocols also, what we are adding to remove increasing of the calcium content and increasing of the milk productivity and structure. These all are trade secrets of the RGMCT, not Sivareddy. This one we established at అయిపోయింది సార్ ఇంకా రాలేదా చూడండి. So you have any doubts you can ask, otherwise the next section will continue soon. Generally why we are visualizing this all labs means just motivating the faculty to introduce something to the student community, especially mechanical. The tradition branches at present they're facing so much of problem for sustainability, but we are the creators of future. That's why we are encouraging our colleagues insist something according to local demand. As a mechanical engineer, what we can do for enhancement of entrepreneurship. If we work like this, next coming 5 years, 10 years, mechanical is the number one branch, no doubt at all. Because without mechanical, nothing will sustainable. So I think you have any queries, you may ask in chat box or directly unmute yourself.
Good morning, sir.
Yes.
Sir, good afternoon, sir.
Yeah, good afternoon.
Sir, shall we start the session?
Yeah, if everyone is ready, I can start.
Yes. So, dear participants, so good afternoon and welcome to the afternoon second part by Dr. Panikumar sir. So, before handovering the session to Panikumar sir, we would like to introduce. So, Panikumar sir graduated mechanical engineering from JNTU Hyderabad. After that, sir did the MSc research in aerospace engineering, IISc Bangalore, PhD from Tennessee Technical University, USA. So after that, sir also did postdoctoral research, University Western Ontario, London, Canada. Sir is having vast experience in the research organizations like NIOT as a scientist F in Chennai. Sir is working on low temperature thermal desalination plants, islands, power plant, barge mounted, and solar desalination, coastal protection structures for wind turbines, and also worked as a project scientist C in Infosys Hyderabad. There, sir worked on a numerical ocean modeling with MOM and ROMS, and postdoctoral fellow University Western Ontario. There, sir, did the work on bluff body wake studies and bulk motions in agitated beds, and also worked as a research engineer at a Center for Electric Power, Tech real-time monitoring of coal-fired power plants. Also worked as software engineer. So devise drivers to convert legacy applications into IP compliant programs. Sir is also a member of various professional bodies, IEEE, OES, OSI, INDA, ISH, Fellow of Institution of Engineers, and also published more than 35 referred journals and conferences in the reputed journals. So with this, I welcome Dr. Sri Panikumar sir. Mostly when I see the speakers, somebody they are multi-talented. So you are also one among them. You are also a software engineer as well as a scientist in various work as a scientist in various categories in research organizations. So you are also multi-talented, sir. So we have to utilize your services. So thank you, sir, for accepting our invitation to give an expert talk on design and implementation of 10 to 50 metric cube per day capacity solar-based multi-effect desalination plants for remote coastal villages. So in renewable under this FDP. So thank you, sir, and welcome. Over to you, sir.
Thank you very much, sir. I would like to thank the organizers for giving me this opportunity. I hope I am audible.
Yes,
Without
sir.
without much delay, I would like to start my presentation.
Sure, sir.
Sir, it is saying I want
Sir,
to.
you wait for 1 minute, sir. I have to
Okay,
give
okay,
permission.
okay, okay.
Now you can share, sir.
Okay, sir. Okay.
Now it is okay, sir.
Yeah. Okay, sir. Uh, Okay, this is the topic of my talk, small capacity solar-based multi-effect distillation plants for water-scarce coastal villages. As Siddha Reddy sir was saying, this is part of the work that we do at NIOT. So I will go into the topic straight away. This is the outline of my talk. I will briefly introduce the topic, then talk about solar energy in India, solar collectors, the types of them, multi-effect distillation, the various steps involved in the distillation process, and also the solar-based MED plant that we installed in Kanyakumari, and then what work we can do in this area. And there was a request for touching upon the tidal energy. So I'll be briefly touching the tidal energy details that NIOT is involved in, and also where tidal energy is available around India. So this is the outline of my talk. As I indicated earlier, if you have any doubts, please feel free to indicate, so that my feeling is only with doubts I can explain you more. Okay, I will get into the topic. Solar based desalination is the topic that we are dealing with. Actually, when we are living by the side of the sea, in most instances, water should not be an issue. But as the saying goes, water, water everywhere, but not a drop to drink. sometimes it is possible that because of the land contamination, the land water may not be potable. So even though the area is coastal, we may still end up needing water. This technology that we are dealing with, deals with uh, giving potable water in small capacity using solar energy to remote villages. By that I mean small capacity plants. Okay, the same thing can be used. Whatever I am talking about can be used if there is any brackish water source, or at the same time we can also take the part of the technology and we can use it for designing, say, rooftop solar heaters or something like that. So there are various byproducts, as in any research. So we can use this technology any way we want, depending on the need. So um, the talk may be useful, or the design may be useful for capacity up to 50,000 liters per day capacity. That means villages of that size. Uh, Coming to solar energy within India, India receives solar energy in the range of 3 to 6 kilowatt hours per meter square. And when we look at various regions of interior Andhra, where we are right now, we may be talking about somewhere between 4.5 to 5.5 kilowatt hours per meter square. Okay. And thus India has a vast potential to harness solar power. Uh, at present, the total installed capacity in India is around 36.9 gigawatt, and around 42 solar parks were established to promote solar plants. And also rooftop solar power, solar lanterns, and water heaters are some of the potential applications for major impact. And when we say for solar power, photovoltaic cells that produce power directly are the applications that are mostly used. But at present, concentrated solar power is also being used in various places. When we say solar collectors, there are various types of solar collectors. Uh, Flat plate collector, evacuated tube solar collectors, parabolic troughs, and also point focus collectors, and solar towers. Okay, all these are solar collectors, so to say. They collect the solar energy, concentrate it on a medium like fresh water or low boiling fluid, and heat that low boiling fluid, and the heat available in low boiling fluid can be utilized in various areas. So uh, uh, they, the solar collectors that we are talking about may vary vastly in terms of efficiency. Like flat plate collectors can give you water up to 50 to 60 degrees centigrade. Evacuated tube can give up to 60 to 80 degrees centigrade. Linear and parabolic troughs can give you water up to 120 degrees centigrade and 6 bar pressure. And so there is something also called as solar tower, which follows the sun. Actually, parabolic troughs also can follow the sun, and thus uh, uh, they will track the sun throughout the day, and also concentrate the energy onto a central collector where the working fluid will be heated, and we can use the heated working fluid for various applications. So usually when we see any collectors, if we are talking about high efficiency, the maintenance also will be high in terms, high for those applications. One common problem with solar collectors is because of the way it is installed. If it is prone to dust, settling of dust, the efficiency of the solar collector will come down. So we have to maintain it in very clean condition throughout the day. If the application doesn't effort that much of cleaning, there is no harm in going for low efficiency applications and aiming for a rugged, constant performance equipment rather than equipment that can vary drastically once the cleanliness degrades. So this is a schematic showing concentrated linear Fresnel type reflectors. Basically, when we talk about solar collectors are oriented in terms of the latitude. That means the degree. When you install the collector, you should install in such a way that the collector will make an angle to the ground. This angle is more or less equal to the latitude on which uh, uh, you are placed. So that is one parameter that we need to take care. The second parameter is the collector itself will be oriented from the north to south direction. And since we are in the I mean the collector will be oriented uh, in the in the east-west direction, but looking south, since we are in the northern hemisphere. Okay, so sun, when it goes from east to west, its concentration on the collector will not vary in a day. That is the second point. The third point is uh, right from the 9 a.m. sun. That means at the location where we want to install the solar collectors, at 9 a.m., there should not be any shadows. And at the same time, at 4 to 5 a.m., there should not be any shadows. That means instead of the solar field that we are talking about, the ground should be clear of any obstruction in the east-west direction up to that distance when so that 9 a.m. sun doesn't cast a shadow on the solar field, 9 or 8 a.m. If a shadow comes, the total solar energy available for the solar collector will reduce by that much amount. Uh, Here we are still talking about linear, compact linear Fresnel reflectors where uh, sunrays will be falling on the reflector, and there is a central collector which has the working fluid. Okay, and all the reflectors are arranged locally in such a way that they reflect onto the central member carrying the working fluid. And when we call any object a reflector, usually what it does is the collector, what it does is when sun rays fall on that object, it concentrates like putting under a microscope or lens. It concentrates all the solar energy onto a point so that at that point the working fluid can be heated. Okay, and depending on the efficiency of the concentration, the various classifications like flat plate, evacuated tube, and things like that will come. Okay, and various applications have been envisaged using these solar collectors. People have used this application to generate power using this application. Basically, we run a Rankine cycle using the heated working fluid so that the heat energy can be converted into electrical energy, and also the entire thing will be running in a closed cycle. these are some of the fields that employ concentrated solar power technology. You can see parabolic collectors and also a central collector to get the energy, concentrated energy. And cost wise, these are the this is what we are talking about. For about 100 meters square, flat plate collector will cost around 22,000 rupees. Evacuated tube collector will cost around 27,000 rupees, and a parabolic trough collector may cost around uh, 31,800 rupees. Okay, and um, uh, when we talk about let us say 1000 meters square, the cost doesn't go linearly, but I mean the cost goes linearly there, but there are no other costs except for the installation cost. So the cost will be doubled for 1,000 meter square area, where we are talking 10 times increase in the area. The cost will be doubled for flat plate, whereas evacuated tube, it is from 21,000 to 47,000, and parabolic trough to 31,000 to 52,800. So for any technology, there is a minimum range that is needed to utilize the technology, so that we are using the technology optimally. And this graphic shows the flat plate comparison between flat plate collector, evacuated tube, and parabolic trough collectors. Uh, as I told before, the flat plate will operate between 55 to 75 degrees, where 75 degrees is the maximum. Evacuated tube between 60 to 80. In some cases, it can go up to 120 degrees. Parabolic trough can directly give you steam at 120 degrees. So heat generation also, flat plate is slow, evacuated tube is fast, and parabolic trough collectors are the yeah, they are the most efficient in terms of present day market. Heat loss is high in flat plate, medium in evacuated tube, and low in parabolic trough. And uh, thermal efficiency wise, parabolic trough collectors are efficient up to 60 to 80%. Uh, and the bottom right hand corner gives the variation in solar irradiation from morning to evening. If you see, uh, first of all, based on the efficiency, the peak solar power that we can get varies from application to application. At the same time, we can also see that initially at let us say 6 or 7 a.m., even though the sunrise has already occurred, the total available energy is not high. It will start picking up only at around 8 a.m. and it will reach a maximum to the design limit only at around 9. So even though we say sunrise to sunset is 12 hours, we have to take only between 8 to 4 as the total working hours. And at the design stage, to take care of various uncertainties, there is no harm in designing the entire application for 6 hours of available solar power. That it completes the section on available collectors. If you have any questions, please feel free to ask. Okay, let me go to desalination techniques. Basically, when we say desalination, we are converting seawater into fresh water. So various available techniques for desalination are distillation, vapor compression, reverse osmosis, and electrodialysis. Reverse osmosis and distillation are most widely used, where reverse osmosis you can see even in your household applications, whereas in the Middle East, where oil is cheap, people use petrol to heat the water up to 6 bar pressure, that is 120 degrees, and then use multi-effect desalination, which I'll be explaining shortly, to convert that vapor into fresh water. Okay, that is thermal desalination, where we are talking about boiling water, getting the vapor, and then using cold water to condense the vapor so that we can get fresh vapor, fresh drinking water. Apart from multi-effect, there are various types in thermal desalination. One is multi-effect. That means the top temperature of 120 degrees centigrade to the bottom temperature where we discharge at around, let us say, 48 or 50 degrees centigrade. Okay. Each stage where I will be desalinating, it will handle only 5 degrees of temperature drop. Okay, and it will go to the next stage. That is first part. Second part is, on one side I'll be condensing the vapor, on the other side I'll be heating the fluid that is going to be evaporated in the next stage. So this way I'll be utilizing the heat to the maximum. So depending on the technology that we are using, we can go by multi-stage flashing, where we will be flashing at 7 to 10 stages between 120 degrees and 50 degrees. People can go up to 14 stages in this process. Okay, and multi-effect, which I will be talking about shortly, deals with evaporating on one side and cooling on the other side of the tube, shell and tube condenser. Okay. Uh, Other type is vapor compression, which is basically mechanical energy compressing the vapor to get the to condense it. Basically, vapor, when it is brought to a certain pressure, it will condense, because beyond the temperature it cannot be stable. So vapor compression uses that principle. Then the other types of desalination are reverse osmosis, which will be done through membranes, and electrodialysis, which also uses some sort of membranes. So membrane, thermal desalination, multi-stage flashing, multi-effect desalination, vapor compression, and solar distillation. These are the various processes. Membrane, reverse osmosis, and electrodialysis. Uh, what type to use and what technology to use, it depends on various factors. Especially the first and foremost is end use. Like in power plants, we may need 2 ppm water for boiler makeup water. Okay. And for potable water, the water should be below 500 ppm. The total dissolved solids level should be below 500 parts per million. Okay. Then what are the water sources? Is it fresh brackish water, or sea water, or river water that is not clean, and things like that? Okay. And availability of the electric power and things like that, and cost and availability of the labor, and maintenance requirements and things like that, and lifespan of the water supply system, and economic value of the region. These are various factors that will determine what technology we will go in and things like that. Coming to multi-effect distillation, as I briefly told, multiple uh, multi-effect distillation has effects where feed water is sprayed on the tubes carrying vapor from the previous stage. That means feed water will be vaporizing on the outside of the tube, whereas this stage I got vapor by evaporating. The vapor will go to the next stage into the tube, so that when the feed water evaporates in that stage, using that heat, it will get the heat from the vapor that is obtained from the previous stage. So the temperature is adjusted between the effects in such a way that between those two stages, the temperature difference will be in such a way when what is it? Mm, Vapor comes into contact in the next stage, it will automatically condense because of the temperature. And on the other side, because of the vacuum, it will, what is it? It will evaporate immediately, losing, getting the heat from the cold water on the, vapor on the other side. During the process, a vapor in the tube condenses and it produces fresh water. Each stage essentially reuses energy from the previous stage, and successively lower temperatures and pressures are obtained after each stage. So from a top temperature of let us say 120 degrees or 60 to 80 degrees, with each stage I will be cooling the water by let us say 5 to 7 degrees and coming to the bottom temperature of around 50 degrees. And usually in all these thermal desalination, the last stage will be a kind of conventional stage where vapor will be on one side and cold water will be on the other side, and the last stage condenses using the cold water. Okay. When we talk about concentrated solar power, we can use it for various purposes. This schematic shows uh, the uh, uh, application for generating the power from concentrated solar power, concentrators, so to say. Okay. How do we do that? When we see any steam turbine or coal-fired power plant, we heat water to the required temperature, okay, using coal. And then once water goes to that stage, we generate steam and then use the steam to generate power. This is how a conventional coal-fired power plant works. What we do in with solar power is, using the concentrators, we generate 6 bar pressure steam, okay, and then we can use it to collect in a central tank, and from the tank we can pass the steam to a steam turbine, so that we can extract energy and then pass the low temperature steam to the collectors again in the cycle, so that it can be used for heating. But the limitation of this scheme will be the efficiency. Maximum energy that I can extract from the system will be governed by Carnot efficiency. That means the delta T for the steam when it goes through the turbine, uh, when compared to the bottom temperature in Kelvin. That will be the maximum efficiency that I can achieve in the system. What we do differently with multi-effect desalination is, we, instead of converting it to energy and then using it to electricity and then using the electricity for a different purpose, where we can directly take it to application like heating water and using that heated water to desalinate, we are cutting down on one intermediate stage, so efficiency will be increasing in the process. What we do is you use concentrated solar power to heat water either to 6 bar pressure or to 60 to 80 degrees centigrade. Then each stage we condense the water in one and on one side and uh, uh, generate fresh vapor on the other side so that we can get the fresh vapor. So this is a system that we installed in Kanyakumari. Basically, it has two components. One is the multi-effect desalination system that I was talking about. The second one is the solar collectors, which as I already indicated, we were using flat plate collectors so that the maintenance and all those things are reduced, and also replacement will be easy instead of importing the failed component from outside, which will be the case if we are going in for Fresnel type collectors. Okay. And there is a third component actually when we come to this system. The third component will be the pre-treatment that will be required for the intake water. One is we have to get water from the sea, so there will be an intake system that will be installed in the sea, and from there a pump will be operated to give water to the concentrated solar collectors. That is the first part. Second part is the multi-effect desalination system. It is like for the 10,000 meter cube per day capacity that we are talking about, the figure that you are seeing in this, it the integrated flash chamber condenser will be of a size of 1 meter diameter. The tubes are spaced out in that diameter. So when we spray water, the spray should reach all the tubes. So we will be using sprayers of very high efficiency when we spray water. And that sprayers in effect will be spraying the liquid to 1.5 meter wide in uniform manner, so that all the tubes will get the same amount of liquid once the spraying is done. So that input for that sprayer nozzle should be at 2 bar pressure. That is one aspect. And the nozzle itself is specially made so that it can spray the liquid in a flat profile up to 1 meter wide. Okay. Uh, so this is one thing. And the second thing is, because of its construction, any small sand particles that are there in the seawater, it may lead to clogging. So the input water should be free of any sort of impurities or sand particles or anything like that. So there will be a settling tank and another pump so that it can transfer the water to the desalination system, and one flash evaporator so that it can generate steam in the 0th stage, and also one conventional condenser in the last stage to convert the last stage steam into fresh water. This is in general a solar based multi-effect desalination system what we deal with for any application. And what we did as part of our studies is we conducted detailed studies on various input parameters and also how the design will be varying and things like that. The table that I am presenting here deals with shows how effect to effect the inlet temperature and outlet temperature will be varying. Okay. And how the pressure also will be varying when we talking about the uh, pressure inside the condenser. So if you see, uh, for the Kanyakumari case, we were operating with flat plate collectors where top temperature is 65 degrees. So flash chamber, the input is around 55. Then output from that will be at 65 to 55. Then first effect, we will extract around 3 degrees, 55 to 52 degrees. Then second effect, 52 to 48. Then third effect, 48 to 45. Then fourth effect, 45 to 40. And condenser will be operating between 40 degrees and 35 degrees. So this is how a four-stage multi-effect desalination system will be working in terms of production. We will be producing roughly about zero 0.2 kgs per second in each of the things. And one of the aspects that we should be seeing is per day we have to produce 10,000 liters. That is the capacity of the what is it, design capacity of the plant. So assuming 8 hours of operation, we need to produce around 1.25 kf, 1.25 uh, or 12 uh, 1250 liters per hour. That should be the capacity per hour. So when we convert that into kgs per second, it will come to around 0.2 kgs per second. This is what we are dealing with. So apart from that, we also conducted detailed studies. Actually, going back, had we designed for only 6 hours of operation, and had we taken the next level of collectors, that means evacuated tube collectors, the bottom table will give you the design for around 50,000 liters per day capacity plant, where the per effect the production is around 0.75, and we are talking about 4 stages still. And what is it, the temperature variation is between 85 degrees to 45 degrees, where in the first stage we are extracting 85 to 65, second stage 65 to 60, 60 to 55 in third, uh, then 55 to 50, 50 to 45, and the last stage is between 45 degrees and 40 degrees. So in terms of requirements for various capacities, this table will give you how the design will vary when we are talking about 10,000 liters per day. That means it is a very small capacity. Per day, we are giving around 1 tanker load of water. Whereas when we go to the highest capacity, 50,000 liters per day, we are giving it around 5 tanker loads. Okay. So from total surface area required in terms of tube surface area, it will increase from 70 meters square to 300 meters square. And pump power will increase from 15 kilowatt to 40 kilowatt. Okay. And area requirement for solar collectors will be increasing linearly only. So it will increase from 700 to 3000, where 3000 700 times 5 will be 3500. But since we are going to evacuated tube, that 3500 requirement has come down to 3000 meters square of solar collectors area. Okay. Then cost, we are talking about around 7 crores per 50,000 liter per day capacity plant, and 2 crores for the 10,000 liters per day capacity plant. Okay. And roughly we will be looking at 2,500 population for 50,000 liters per day. Okay. And cost per liter, if we purely see the economics, it will come to around 0.47. Whereas considering everything. Actually, this 47 paise per liter will consider the cost to run the plant. Then it will consider the capital that is invested in the plant. Okay. And even the maintenance that may be required over a period of 20 years. So if we consider everything, the cost per liter will come to around 0.47 rupees per liter. But the same thing if we see in a different scenario, like under some scheme which comes under the requirement of giving fresh water to the community, if we can sponsor the capital to the for the plant, for putting up the plant, running and operation of the plant will not be so much. It will come down to hardly around 10 to 12 paise per liter. Okay. So basically the activities that may need are for the plant, designing or establishing the plant, identification of a site, then the community should be willing to take over the plant after the initial. Usually NAOT, what we do is we will be there for technical assistance up to 1 year after the installation of the plant. Then land should be provided by the local community. Okay. They are having come up to this part, what can we do in this area? One is one byproduct of this application is, instead of talking about desalination, if we are talking about rooftop solar heaters, so that I can reduce the energy needed to for bathing and similar applications, then the application may touch the domestic use of entire India. And since the available solar energy is not a constraint, it can be it can be used anywhere actually in the India. It can be designed for anywhere in India. Then we can also catalog the solar radiation at any particular location, so that with sufficient data, we can design better systems. Okay. Then the third thing could be designing or cataloging utility for collectors for any application, like what is it, solar energy from getting electricity from solar energy, or like I was talking, fresh water from solar energy, or rooftop solar applications. We can design the systems, various systems for these applications. So that brings to the end of this half of the talk. Okay. Coming back, this is the cost involved. I already touched. And okay. Yeah. Any questions up to this part? If there are no questions, I will briefly touch on the tidal energy. Basically, when we are talking about tides, tides are a response of the ocean or water body for varying solar, lunar attractive forces due to rotation of Earth and Moon. Basically, the attraction force of sun and moon will be varying depending on where the sun and moon are, on the opposite side or right above our head. And accordingly, the water body will be pulled towards the sun or moon depending on the time of the day. And accordingly, the level of the water body will be varying. So depending on the location, distance from the equator, and some other factors, tides can be diurnal, that means 24-hour period, semi-diurnal, that means 12-hour period, or mixed type where it will be a mix of diurnal and semi-diurnal. Okay, and some regions it will be, they will witness very high tidal variations because of their location and various other geological symptoms, like for example, when we come to the Khambat area, Gulf of Khambat area, Bhavnagar, Ahmedabad, in that area, the tidal range from low tide to high tide in the sea can vary at an average up to 6 meters. That means in this region, if during the low tide, water is at the ground level of your building, okay, during the high tide, 2 floors will be underwater within 6 hours. That means 12-hour period, the next high tide will be coming or low tide will be coming. So within 6 hours, that much of water will be coming into this region and it will go back from that region. That is the average when we come to Gulf of Khambat area. And the maximum observed tidal range has been observed to vary up to uh, 11 meters. Okay, with a maximum velocity of tidal current of up to 3 meters per second. That means normally in the ocean we go by current in terms of knots. That means 1 knot is 0.5 meters per second. A 1 knot current is very high in terms of a ship sailing in ocean. It has to exert lot of energy to overcome 1 knot current. And when we are talking about 3 meters per second current, we are talking about uh, currents of 6 knots velocity. So it will be very difficult to even work in this area. That is one of the minus points when we talk about tidal energy. But at the same time, imagine a region where in the bottom left-hand corner you can see uh, Bhavnagar to the other side of the coast in the Gulf of Khambat. We are talking somewhere around 50 in the northern regions to around 150 kilometers in the southern regions. I mean, not 50, around 15 kilometers to 50 or 60 kilometers in the southern region. You imagine that much area seeing water level differences of the order of 6 meters variation from morning from in a 6 hour span. That means huge amount of water is coming and going. So naturally we can extract lot of tidal energy in this region. But as I was indicating, the difficulty with the currents, for extracting the tidal energy, I need to have a tidal turbine installed there. Installation means I have to fix the tidal turbine to the ground, and that also means.
वो तो
Hello?
ऐसा ही है, उसमें एक कमरा तो पीछे बन जाएगा पूरा 14 बाई।
Hello. Okay. So I was talking about installation difficulties. When we are talking about boats being difficult for boats staying there, okay, we are talking about installing huge objects in the seabed, where seabed could be of the order of 20 to 50 meters depth in these regions. Okay, so the project is a huge one and it is a challenging one. And Kalpasar, that way, it is planned to be a three-part this thing, 3 parts, where the rivers Narmada, Tapti and Damodar, they will be discharging into one part. Over a period of time, it will become as a large freshwater lake. Okay, then the excess water will be spilled over to the next region, where the second region will be acting as a buffer between the river basin and also the open ocean. So actual tidal turbines will be installed between the this buffer region and the open sea. So they um, when we come to tidal turbine, basically it is a basic turbine. So to say, in crudest of the terms, it is a fan. Based on the current velocity, the fan will be rotating, and where a fan uses energy to rotate, here the fan will be rotating to run a generator and then produce electricity. So the research into the turbine will deal with designing the fan blades in such a way that irrespective of the direction of the current, the fan blades can be rotating, and in both the currents, forward and reverse direction, the efficiency is not affected by that much. Okay. And then the second part is the fan blades should be able to withstand the loads that are caused by the water. Okay. And also it should take care of the total range that is involved. That means the 6 or 11 meter range that I was talking about, and the design of these blades to give maximum efficiency for the condition that we are designing for. That means the local wave, weather, climate, then currents, and also the tidal range. Okay. One of the projects installed in South Korea, the Siwa Lake Tidal Power Project, a figure of that is shown in the right-hand corner of the slide. Okay. Basically, there should be one more slide. Okay. Yeah. This talks about the, yes. This is not a repeat slide actually. This talks about the, what is it, NIOT's involvement up to now in Kalpsar project. We have done detailed bathymetric studies. We have mapped the entire floor of Gujarat, that Gulf of Khambat area. Okay. For this, to take care of the local loads and things like that, we have had to design various instruments, and also we had to employ various techniques so that we could get continuous readings. We were able to achieve that. It was a massive project involving various locations and lot of people, and also around 3 to 4 years of work. We were able to complete that part. Okay. And right now the government is going forward in preparing the pre-project documents to invite global tenders. So we are in the process of getting involved in this part also, where we'll be advising on the various aspects like design and current and wave related information. We are involved in this area. Okay. This brings to the end of my talk. If there are any questions, please feel free so that I'll be able to answer them. Yes.
Sir, how much energy is required to desalinate this 1 liter of water?
Yeah, just a minute. Yes. Roughly, we are talking about somewhere around four, 3 to 4 uh, units per liter of water. That is what we are talking about when we are talking about solar desalination. But one of the aspects of solar desalination is whatever energy is needed, since it is a solar application, we will be getting that energy also using photovoltaic cell. So we are not using power, so to say. We are not using the grid power.
Okay, okay. Suppose you have shown some big plants,
Yes.
but you see the locations like Ladakh. There
Ah,
we have to treat the glacier water.
ah.
So which kind of desalination system will work there for
Uh,
small communities?
that's a very good question, actually. First of all, we need desalination when there is salt in the water.
Yes, yes.
Okay, when we go to Ladakh, most probably it is either brackish water or it is pure water frozen into what is it? Frozen into ice.
Yes.
Okay, but one of the aspects in the northernmost regions, when we go to that slide on solar irradiation, no, in these high latitudes, the amount of solar energy that is received when the sky is clear is very high.
Yeah,
So,
DNA is high.
ah, so we can directly use the solar energy to heat the water to up to the temperature that we need, and we can devise one application where using the heated water we can defrost the ice.
Okay.
Okay, so that means basically we should be dealing with the latent heat that is needed for converting ice into water, and water at 0 degrees to probably somewhat drinkable temperature of say 16 to 20 degrees centigrade. Okay, then we need to design the system.
No, but sir, there is one problem.
Ah,
Here, the population density is very low. So we
ah.
cannot go like big plants at one area. So in that case, which kind of system will work? Like we have a low barometer system, desalination system, and we have multi-effect humidification, dehumidification. So many
This
systems we have.
solar desalination may work if it is not cloudy all the time. That is, solar desalination is one of the things. It will work directly. We'll be talking the capacity that we were dealing at Kanyakumari deals with 10,000 liters per day.
Yeah, yeah.
Okay. Probably if the population is low, I may think about even 1,000 liters per day
With same technology.
with the same technology.
Okay, okay, okay.
Okay,
Thank you.
so and we are not desalinating, so there is no need for heating, evaporating, and all those things.
Yes, yes.
It will be a variant of let us say our rooftop solar heater that we use in our regions. Okay,
Mm-hmm.
it will be a variant of that, so that we can use first to defrost. If on the top of it we need to do anything, we can use low quality membranes, or so to say Rama filters, to make brackish water into potable water.
Thank you, sir.
Okay. Any other questions? Sir, any other questions are there?
Sir, nobody is asking questions, sir.
Okay, sir.
Okay, sir, let me ask one more question.
Yes,
Yeah,
sir.
please.
We have one more plant in Ramanathapuram district.
Ah,
That is also, what is the difference, this Kanyakumari plant and that one?
Ramanathapuram was designed using linear Fresnel type.
Okay.
Okay. and Ramanathapuram is slightly interior. Okay, we still have access to sea, but probably some 3 to 4 kilometers away from the sea. Okay, one problem with this solar desalination is plant will work only when there is the sun.
Yeah.
That means it will give water only for 8 hours a day when the clouds are not there. Okay, so initially we have designed the Ramanathapuram to give somewhere around 2 MLD, 2 million liters per day.
Okay.
Okay, the plant is very high capacity. But initial stage, it was also thought that during the non-sunny days or non-sunny hours, we use something like biodiesel to heat the water. Hybrid.
Yeah.
Okay. Now, one problem is that was designed for a KGDS, some private company. Until the time we were there, we were running the system. After we came out, maintenance of the plant became an issue. So right now we are not sure whether that plant is running or not. But other than that, it is a design wise, it is same design with a higher capacity and higher efficiency. So whatever we talked about until now, they are still valid. I think it employs somewhere around 6 stages. It uses steam at 6 bar. Okay. It uses multi-effect desalination. It uses linear Fresnel type reflectors. So all these are the characteristics of that plant.
Okay, yeah, sir. I spoke to Dr. Suresh actually last week.
Okay.
From KGDS.
Okay.
Okay, sir. Thank you.
Okay. Thanks a lot, sir.
Sir, another question from Krishna Raj.
Yes, sir.
Any tidal floating system in India?
Sir, tidal, there are only 2 locations where tidal energy is possible. One is Kalpsar area in Gujarat. The other one is Sundarbans in the Calcutta and Bangladesh region. Floating tidal devices are not experimented until now, sir. But floating wave energy devices are being experimented. Even that way, India is badly located for wave energy. Unless we are talking about a few isolated places, our wave energy is not, incident wave energy is not significant. And any wave energy device, by design, it can give only 18% efficiency. That means if I have 100 in the incoming wave, I can give you 18. 100 kilowatt in incoming wave, I can give you 18 kilowatts. And if you want more, I have to increase the linear span of the wave energy device. That means you want 3 kilowatt, I will put a 300-meter long wave energy device. If you want 300 kilowatt, I will put a 3-kilometer long. So that is the only thing that we do in wave energy. Because of the location, we are in the low latitudes, wave energy is not high in the Indian coast. That way, India is one of the first countries to install a wave energy device in Vilinjam, Kerala. We started it with IIT, and one of the first projects for NIOT is installing that plant in Vilinjam. We use that energy, it's a small capacity plant, 1 megawatt. We use that energy to run an RO system for giving water to the local fishing community up to 2007, I think. After that, we decommissioned it. Yes, sir.
Still any questions? Still anybody? Okay, sir. Nobody is ready for questions. So thank you, sir. So my wholehearted thanks to you on asking. You are accepted in 2 times,
Okay, sir.
phase 1 and phase 2. So successfully you have given the lecture. So thank you, sir.
Thanks a lot for giving me the opportunity also. Thank you very much. Thank you, sir. Thank you.
Bye bye, sir.
Okay. Thank you, sir. Bye.
So this is the today's dear participants. This is the today's sessions. Tomorrow we'll have the. Sir, anybody want to talk?
उसमें आपके 4 कमरे आराम से
जितेंद्र कुमार।
वो है 4 कमरे बनाएंगे और 2.5 लाख का करोड़ कहाँ से आएगा?
अभी
So tomorrow we'll have the talk by Dr. E. Anil Kumar, Associate Professor in the Department of Mechanical Engineering, IIT Tirupati. So sir is going to deliver a talk on solar thermal operated cooling systems for industrial, commercial and domestic applications. So all of you join in the tomorrow at 10:30 a.m.